Alright, so today is September 3rd. We're going to have another lesson. Today's lesson will be short because we'll be having the quiz later on at 11:20. So I'll finish the class around, say, 11:15ish or 11:10. That way you'll get a little bit of break to grab a snack or something, or even just something to drink. So, and then you can start the quiz at 11:20 and it'll end for you at 11:40. But of course, you don't need the entire 20 minutes to finish the quiz because it's pretty short. It has 3 to 4 questions, and some of them have parts, but still they're doable within, I believe you can do within 5 minutes. But take your time, don't rush through. Remember, once you submit an answer, you can fix it. So make sure you have the right notation written before you hit submit. Be very careful how you input your answer. Okay, and you only have one trial, so don't miss it, okay? Once you have the right answer written in your paper, then go to the computer or whatever device you're using, type in the answer. And I will be here until 11:40 just in case anyone runs into trouble or if you have any questions. But of course, not quiz question because I can't help you with quiz question while you're taking the quiz, right? So just keep that in mind. Any technical difficulties, maybe I can try to help you with, but hopefully you're all set for 11:20 to 11:40. Okay, so any questions on that? All right, looks like you were good. Hopefully you guys had a nice Wednesday off. um, so let's go ahead and start our lesson for today. I will do I will finish up absolute value, which we started last time, and then we'll do some questions to review for P2. Then we'll move on to P3. Okay, if you have questions, you can use your audio to communicate with me, and try not to post anything on chat. All right, so I'm gonna go ahead and start. So yeah, go ahead. Yeah, it's on WebAssign. So it will show up exactly at 11:20 under assignments. All right, so we were finishing up P2. So let me just start with that. So continuing with P2 from last time, we were on absolute values. Okay, so absolute value is denoted by this symbol where you have two vertical bars and you have a variable in the middle. And we define this as a piecewise function, which we will talk about much later in the chapter, and we'll learn how to graph them as well. So if you haven't seen it, be patient. Okay, so it's going to be A if A is greater than or equal to 0, meaning positive, and it's going to be negative A if A is less than 0, meaning negative. So think of it this way. Let me give you an example to illustrate this idea. If you have, say, if you're looking for absolute value of -5, right? Well, by definition, here A is -5, so we're really looking at this definition right here. So to evaluate this, you will do negative times A, where A is -5. And we know from our laws from, the properties from real numbers, negative times negative is positive, so this is a positive 5. Okay, so in other words, absolute value of any number is always positive. Think of another example. What is absolute value of 25? Well, by definition, absolute value of A, if it's greater than or equal to 0, then it's just A itself. So absolute value of 25 will simply be 25. So hopefully you have seen this in your earlier studies. If you haven't, well, this is what it is, okay? Now, there's another way we also like to use absolute value. we like to use absolute value as a distance between two numbers, okay? Because distance is always positive, so we want to consider using absolute value. So also we have distance between two numbers, right? Distance between two numbers, let's say real numbers. A and B is defined as, so I'm going to give you the notation. So the distance D between A and B is going to be the absolute value of B minus A. Okay, so that's another way you can also think of absolute value, just simply the distance between two real numbers. So for example, if I want to find the distance between, so find, let's say, find the distance between 7 and -2. Okay, so if you want, you can draw these numbers on the number line and count how apart they are, or simply use the absolute value definition to find the distance. Okay, someone want to give me the answer? Yeah. Okay. Go ahead if you raise your hand. Uh-huh. Sorry, I didn't catch that. Come again? Oh, 9. Yeah, okay. So we know the distance between 7 and -2 is going to be, also someone told us it's 9. So I didn't catch your name. Who was it? Ismail? Was that you? Okay, thank you. So Ismail says it's 9. Well, we use the formula, right? We do absolute value of B, that's -2, minus A, that's 7. So that would give us -9 in absolute value. And we know absolute value of a -9 is +9. So, good job. So that's another way you can also think of absolute value. More importantly, we're going to be using this definition because that's the most formal definition of absolute value, and we'll use that to also construct the graph of absolute value function, which we'll do later on. So that's the end of P2, which I didn't get to cover. Well, I didn't get to do example last time, but there it is. Okay, again, let me know if you have questions. Try to use your audio to ask questions. Can you guys hear me? I'm not sure if it's just Jasmine. Okay, so Jasmine, maybe reset your audio, that way you can hear me. Cool. Right, perfect. So let's do a couple more examples on P2, that way we can review a little bit. Hopefully these materials are fresh in your head for the quiz. So here's an example I cropped from our textbook. It's a nice example to work on. So let's call this example 1. So you're given 3 sets, A, B, and C, and here is the question. Part A, find A union C, and part B, find B union C, and part C, find B intersect C. Okay, so just we're gonna consider these 3 sets and try to find these new sets, part A, B, and C. So the best way to start these problems, I would say graph it. And so that way you have a visual idea of how these sets look like and what are the elements they contain. So let's draw A. Okay. So here's the number line. And A is the set. So you read this definition as X, the vertical bar means such that X is greater than or equal to -2. So everything that's greater than or equal to -2 is included in the set A. So this is set A. So let's suppose this is -2, greater than or equal to, so it's a closed circle, and greater than is to the right. So that's set A. Now let's do set B. So here's the number line. B contains x such that x is less than 4. So everything that's less than 4 is in the set B. So let's suppose 4 is here, open circle because it's strictly less than, and then we go to -infinity. And now let's draw C. So C is going to be the set everything between -1 and 5, not including -1, including 5. So let's say -1 is here, open circle because it's not including, and 5, let's say 5 is here, and including 5, and everything between them. So that's set B. So now that you have a visual idea of these sets, how they look like, and what are the elements they contain, we can now write down what is A union C, what is B union C, and what is B intersect C. So can someone tell me what is the set A union C? Well, first of all, what does the symbol union represent? Right, so we include everything from the two sets. We include A and we include C. So A contains -2 to infinity, and C contains -1 to 5. So what will be their union? So who can tell me the union? So come again. 0 to 5. So if you include 0 to 5, right? So it mm, less than or equal to 5. No. So okay, -1 to infinity. But what happened to -2? Do not include that? Right. So it'll be everything from -2 to infinity because it has to be in A and it has to be in B. Sorry, in C. Well, so here's the thing. I don't have to include -1 with open circle because -1 is already part of A. It's already in there. So although C doesn't have -1, but A has it, so I have to include it in the set. Do you see that? Right? So basically, right, so it's gonna start from -2 bracket and all the way to infinity. Because this set C is already within that interval. It's already part of A. So when you include -2 to infinity, you are including -1, 5, and everything in there. Does that make sense? Oh, no, no, that's fine. You could graph it, but if you were to graph the set A union C, that's exactly same as A. So this is pretty much the set A. Do you guys see that? Mm-hmm. All right, no problem. All right, hopefully that makes sense. So again, if you see, set C is a smaller set, which is already included in A. So if I were to copy C and put it on A, well, it's right here. It's already there, right? It's already part of A. So when you're doing the union, it's just everything what A contains initially. So wouldn't really have to do much. But you really have to think about it, right? So uh, just do the drawing if you have to, if that helps you to better understand these questions. Now for B union C. So who can tell me what's the set B union C? So negative infinity 4 bracket and what else? All right, so that will be like that. Yeah, absolutely, right? So B union C is basically everything that B contains, which is all of this. And then, well, C also contains all of that, but we also have to go a little bit more to 5. So it will be negative infinity open all the way up to 5, including 5 because C contains the number 5. Okay, let me know if that makes sense. Uh-huh. Well, yes, because now you have switched the order on the real line. It has to go from lowest to highest. Okay, so we wouldn't put this. You always go from the lowest value to the highest value because the real number is in order. It's well ordered, right? It has numbers in ordered fashion. So we want to make sure we follow that when we write interval or inequality notation. No problem. All right. Any questions? Okay. Yeah. You have to read the question on the quiz. It will tell you. So be very careful what they're asking for. All right, so moving on to part C. So now we're looking for B intersect C. Well, what does that mean? Who can tell us? Absolutely. So if you look at B and C, what they have in common is from here to here. So that's the tiny set that's in the intersection. Uh-huh. Oh, it's recorded. I'm recording in a different software. Yeah, it'll be up on my YouTube videos. And I'm doing it this way because it gives us a better resolution when you view it later. That's why. But thank you for checking in. All right, so any questions on union and intersection? Hopefully this makes sense. Let me know if you guys have questions. Moving on to another problem. So here's another example from our textbook. So for this one, we want to express the given set in interval notation. So I'll give you a couple of seconds and write down your answer. Go ahead if you have a question. Oh, you want to answer it. Okay, so let's have you answer the question for us. Absolutely, right? We use bracket because it's closed, so that gets a bracket. And this is also closed, so bracket. And the numbers are negative 3 and 5, so everything between them is in the interval notation. Cool. Great. So let's do a couple more examples. So these questions are absolute values. So we're going to evaluate them. So I'll give you, again, a couple of seconds to work on these. Okay, so here are 3 problems on absolute values. So evaluate. Okay, so 3, 4, 5. Okay, so take a couple of seconds and then I'll call on a volunteer to tell us their answer. Yep. Go ahead. Yeah, they will be up on my YouTube channel. Uh-huh. Yeah, no problem. I do so that way you guys can revisit if you need to go over an example or something. Sure. Uh, it depends on the question, right? I'm not sure which question you're referring to. Well, if you give me your question, maybe I can be more specific. Okay, all right. Okay, so let's go ahead and start with number 3. So we want to find the absolute value of 10 minus pi. So let's have Nelson tell us how to do this one. Mm-hmm. Absolutely. Yep. So you want to keep it in terms of pi, so it'll just be 10 minus pi, just removing the absolute value, because the result will be positive. Good. Thank you, Nelson. All right, question? Bug 4? Okay, go ahead. Tell us. What do you have? Mm-hmm. Thank you. Great. So that's number 4. Okay, sure. Go ahead. How do you get 45? Okay, let's stop there. When you're multiplying numbers, we don't need common denominators. Yeah, you just multiply them straight up, right? So, mm-hmm. Good. Right. So that would be the answer. Mm-hmm. So be very careful when you're multiplying. You're welcome. When you're multiplying or dividing fractions, you don't need common denominators. Common denominators are only when you're adding or subtracting. Okay, so just keep that in mind. All right, so great. So you guys did great on these questions. I think I have a couple more. No, I don't. All right, so now we're going to do P3. Any questions before we move on to P3? Well, it's being recorded on Blackboard. So it shows when you're coming in, when you leave. So that's the track I will be looking at. Mm-hmm. Yeah, no problem. All right, any other questions? Uh-huh. No, the quiz will be at 11:20. Yeah. Okay. All right, so let's move on to P3, and then we'll do a couple examples on P3, and then we'll stop at 11:15-ish. So P3 is another very exciting section from this textbook. It's called integer exponents. Okay, so integer means whole number, right? It could be negative or positive or zero. An exponent, I'll define what it means to be an exponent. So here's a formal definition of an exponent. Well, let's make it not too formal. Let me just give you what it means to be an exponent. So suppose you have an expression that looks like this. So here's the form: a to the power n, okay, where n is an integer. So this is what we mean by exponent. What it really means is that you have a multiplying itself n times. So you have a times a times a times all the way up to n times. So n times. So that's what it means to be an exponent. You repeat the base as the number of exponent that appears. So we label n to be our exponent. Exponent is another way of saying power, okay? And a is what we consider base. Okay, so pretty much that's why you have to know what it means to be an exponent. Now let me give you an example with real numbers. So say I want to write 7 times 7 times 7 as an exponential form. How would I do that? Right, absolutely. So this is the way we can write bigger numbers in a very nice form using the exponent notation. And you can also do something like this. So let's call this example 1. Example 2. What if I have 1/5 to the power 2? What does that mean? Right, so now our base A happens to be 1/5. So the base could be a fraction as well. So you have 1/5 repeated itself twice. And then if you want, you can evaluate. So 1 times 1 is 1, 5 times 5 is 25. So that would be the result for 1/5 to the second power. So hopefully you got an idea how to work with exponents. Now before we start doing examples and making negative powers as well, we're allowed to do that. I'll give you some laws of exponents so that you have them memorized or just know how to use them. Okay, you don't have to strictly memorize them. Understand them and see how they work. Okay, and then we'll do some examples. So here are the laws of exponents. So let's call the first law to be, say, a to the power 0. So here my base is a and my exponent is 0. What does it mean? Okay, that's a nice way to think of it, right? 0 to the power itself. What the heck, right? Confusing. So we'll just say there is a really nice proof why this happened to be 1, but we'll need a little bit more knowledge to do that. But for now, we accept it's 1. Okay, so any number to the 0th power is always 1. If you're interested, and if it fascinates you, you can look up the tiny proof. It's really clever how they did it. So you can look that up. Law number 2, we're going to say if you have a to the power n times a to the power m. By laws of exponents, if you have same base and you're multiplying, you can add the exponents. Okay? So the expression for this would be a to the power n plus m. So we keep the base and we add the exponent. So that's second very important law. The third law we have is if you have a to the power n over a to the power m. So now again we have same base, but we're dividing them with different exponents. So the idea is to keep the base and you do top exponent minus the bottom exponent. Okay, so very important rule. Next we have is, say if you have a to the power n to the power m, right? So you have a base that's being raised to an exponent, and that entire expression is also being raised to an exponent. So what do we do in this case? What do you guys think? Absolutely. So you would multiply the exponent, so you have n times m. Okay? And then we can also do something like this. If you have a over b to the power n. So if you have a fraction and the fraction raised to a power, you can, so for this one, I would have you think of this example right here. 1/5 to the power of 2, where a represent 1, b represent 5. So what we did was we expanded 2 times, or you can think of 1 gets a power of 2 and 5 gets a power of 2. And then you evaluate each one of them, which will give you 1 over 25. So that's the law you could also use for this example. So to use that and generalize it, we have a to the power n over b to the power n. So you're allowed to distribute the exponent if you have multiplication or division. Alright, so let's see if you guys have any questions. Alright, Katera, I will try to slow down, but also you can access the notes later on if you want to. So. Uh-huh. Are you talking about law number 2 and 4? Okay, so let's think of an example for 2. So say you have 2 to the 3rd power and 2 to the 5th power. Whereas for 4, think of an example 2 to the 3rd power, and that's being raised to 7th power. Do you see the difference? So for law number 2, we have, let's see, how do I say this? You have one real number here, and the next real number is also the same one, but it's just being raised to a different exponent. Whereas for law number 4, you have just one real number, and that's just being raised to an exponent to an exponent. So hopefully you can see the difference. And then if I were to evaluate these, this would just be keep the base, and then you add up their exponents, 3 plus 5. So this would be 2 to the 8. Whereas law number 4 tells us, oh well, I have 2 to the 3rd, and that's being raised to 7th power, so that's just multiply the exponent, 2 to the 21 power. Or another way to think of it's really coming from law number 2. What this means is you have 2 to the 3rd repeated 7 times. So you have 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. How many is that? 4. 5, 6, 7. Ooh, I didn't realize the exponent I wrote it so big. Okay, well now here you can use law number 2, right? You keep the base, you add up the exponents. So 3, 6, add these up. There should be 21, right? Yeah, 21. So for law number 4, you really have two ways to think about it. You can either multiply the exponent, or you can expand it out and use law number 2. Did I answer your question? Okay, hopefully I did. Let me know if you still have questions. Alright, cool. So moving on, so we got up to law number 5, where if you have division of two different bases, we can distribute the exponents. Now keep in mind, here, can I use law number 3? Question mark. Yeah, right? A and B, they're different bases, so we can't really do anything with their exponent other than just leaving it as it is. So we'll just keep it there. So if they're different base, don't touch their exponents. Unless they have same base, then we have laws that can simplify things for us. Now, just to verify 5, I'll do law number 6. If you have a and b to the power n, right, I have two different bases again, and they being raised to a power n, I can now distribute their powers. So I have a to the power n and b to the power n. So very similar to law number 5. All right. Law number 7, if you have a to the power of negative n. What do you guys think? How do you simplify this? Right, so when it's negative, you flip it over and it becomes positive. So the idea of simplifying is to always make sure we have positive power and the bases are multiplied or expanded if needed to be. And then we can also expand this a little bit more. So 5, 6, 7, 8. If I have AB to the power of negative n. What do you guys think? How do we simplify this one? You flip them, right? Absolutely. So you have b over a, and now it's positive power. So once you flip the fraction, it becomes positive power. Another way to think of this one, right? Or I can distribute the exponent just like law number 5, right? If you have a fraction raised to an exponent, you can distribute the power. So I can do that. So you have a to the negative n over b to the negative n. Well, now here I can really use law number 7, where if you have a negative power on top, you bring it to the bottom. So a to the negative n, I'm going to be bringing that on the bottom, make it positive, because it was negative on top initially. And then b to the negative n on the bottom, to make that positive, I move it on top. So that will be a result. And if you want to write it in a compact form, you can also say this is b over a to the power n. So any of these are fine. So just know that you have to know how to make your negative exponents positive. And then we can expand this a little bit more. The book gives us a few more additional laws. They're just really modifying what we already have. So make sure you know these laws really good, really well, by heart, by whatever organ works the best for you, and then know how to apply them to applications. Okay. Any questions on any of these laws? Okay, so let's go ahead and start with examples. So that's pretty much all we have to know for P3. Know the laws of exponents and know how to do examples with them. So time to do examples. So I have lots of examples from the textbook. So I really like this textbook. They give you tons of examples. So pretty good. We used to use this another textbook for Math 190. That was also one of my favorite books from the same writer, but this is a different one. It's just algebra and trig, so hopefully it's good. I like it so far. So far it's good. So here are two examples, and then I'll give you a couple more in a few seconds. So, a few seconds, think about them, and then we'll go over it together. Go ahead. Right. So you want to write this expanded form in a compact form as an exponential form. So you have 5, that's your base, and it's repeated 1, 2, 3, 4, 5, 6. 6, so 5 to the 6. Great, thank you. Now, can someone tell us what's the difference between negative 5 to the fourth and negative 5 to the fourth? Absolutely. So here, so that's the difference. Okay, draw a line. So here we're repeating negative 5 4 times because that's what the parentheses indicate. You raise this entire number to this power, which is 4. Whereas the second one, the exponent only belonged to 5, not the negative. So you can always think of that negative represents a negative 1 times 5. So you're only expanding 5 4 times. So perfectly explained, thank you. Now let's evaluate. What's negative 5 parentheses to the fourth power? Mm-hmm. So you can do these two first, right? Because multiplication is commutative, as we saw earlier. That will be what, 25? And then you can do the last two. That's another 25. And then 25 times 25. That's a perfect square, right? We should all remember that. 625. Perfect. And what about for the second part? What's the answer? Yep, absolutely. Okay, thank you. Right, so I missed a lot of hands. So do you guys have any questions or answer concern? Okay, so let me know if you guys have questions because I'm missing a lot of hands. Okay, so let's go with this one. So for these three examples, you want to evaluate. So let's call this example 3, A, B, and C. So I'll give you guys a minute to work on A, B, and C, and then we'll go over it together. Okay, so let's have Elizabeth tell us the answer for 3A. Okay, thank you. All right, let's have Ariana tell. Okay, so there is a hand. Um, Aaron, tell us. So Aaron, I believe you have your hands up, or it might be someone else. I'm not sure. Mm-hmm. Absolutely. Thank you. Yeah, sure. You got it? Okay. Okay. Well, let's check, right? So for the first one, you're doing -5 times -5 times -5. And for the second one, we're doing -1 and then times 5 times 5 times 5. Do you see it? Uh-huh. Yeah, that's pretty much what we're seeing right here. So good point. Yeah, good point. Thank you. So if you look at example 2 and example 3, A and B, see, note the difference. You have a negative, you're looking at -5. If you raise it to an odd power, the result will always be negative, because if you have two negatives, meaning even number, it cancels out and you have positive. But if it's an odd power, then these two will make it positive. So, question? So, okay, someone had their hands up. So you can tell me your question or concern. Well, where I'm still explaining the difference between and the even power and odd power. So I'll come back to you once I finish. Thank you. So, uh-huh. So if you notice -5 to the fourth, you have even powers being raised, right? So the negatives will cancel out. And whereas -5 to the third power, you're raising negative number to an odd power. So of course the negative wouldn't cancel out, as we can see it right here. Two negatives makes it positive, but the last one will make your result negative. So even if I was raising -5 parentheses to the fifth power, the result will still be negative. You just have to multiply the numbers. So you can remember that if you want to, or just evaluate really using the laws of exponent. So for this one, it doesn't really matter for A and B if I use the parentheses or not, because the power is odd and the value itself is negative, so the result will be negative. So thank you for that. All right, so coming back to you, he wanted to answer one of the questions from 3, and I didn't catch your name, sorry. Nazir, was it you? Okay, 4. Okay, so tell us, how did you get 4? So what's 2 over 5 to the second power? 4 over 25, right? Because you're expanding 2 and you're expanding 5. So, and then these will cancel out, so you are left with 4. So, good. Thank you, Nazir. All right, so simple examples with exponents hopefully make sense. I have more examples for you to work on. So here are a couple more. So let's call this example 4. Is it 4? Yep. And simplify. Okay, so I'll give you guys another minute to do A, B, and C, and then I'll ask a couple of you to help me out. So, Savara, you asked if the quiz will be on P1, P2, and P3. No, the quiz will be only on P1 and P2, not P3. Yeah, no problem. All right, take another couple of seconds to finish up. Okay, so we're ready by now. So let me call on Omar to help us out with part A. Yep, hi Omar. Mm-hmm. Absolutely. Thank you. All right, so here Omar used law number, let's see, so I forgot how I number them. So we use 2 and then we use 3 and then we just put them all together. So those are the laws being used combined. All right, so let's ask uh, Yusuf to help us with part B. Okay, Aaron? Well, Yusuf, I couldn't hear you. Um, Isha? Okay, go ahead. Mm-hmm. Absolutely. Thank you, Isha. So, yeah. Yusuf, I couldn't hear you for the previous question. So I don't know if your audio is working. But I'll come back to you and you can speak whenever it works. So hopefully it works soon. So let me go to, well, any volunteer for the last part? Anyone wants to try for part C? Okay, what about Christian? Okay, go ahead. Mm-hmm. Mm-hmm. So let me just write it out. That way we have it. Okay, so that's what you did first, right? Okay, and then, uh-huh. Okay, so this will result in negative 54z to the ninth. Yep, thank you. All right, perfect. So great. You guys are doing great. Hopefully all of this makes sense. Um, Here now we have negative exponents. So let's take another a minute or two to work on these two problems. So let's label this one number 5. Number 5. Okay, so I'll give you guys 2 minutes to work on this. All right, so let's go over these. Um, let's hear from um, Kinky. Tell us how to do 5A. Okay, I'm not sure if Kinky is here. Let's see. Okay. Hmm. Nilsson, tell us how to do 5A. Like that? Okay. Okay. All right. Thank you, Nelson. So let's see what Nelson did for us, right? So he divided the numbers 6 and 2, that's 3, good. And then for S, well, we want to put them, so there are two ways you can do this. You can use the subtraction rule, right? So if you go back to the laws, right here for law number 3, you can either do the top minus bottom, or if you want, you can use the law number 7, make it positive, and then use the previous laws to simplify. So what I would suggest you to do is bring this one on top so that it's positive. So if I were to show more steps, so I have 3s times s to the 2, and then for the t's, because t to the negative 4 is negative on top, I'll bring that on the bottom to make it positive. So I initially have t to the 2 is there, and then now I'm bringing in t to the 4th. And then I can use my laws such as adding the powers to combine them. So this would give me 3 times s to the 3rd and t to the 6th, which is the answer Nilsson gave us. So perfect. Any questions on this problem? Okay. Moving on to part B. So who can tell us how to do part B? Go ahead. Okay. Tell me which part confuses you. Okay, so here you have 6 over 2, that's 3, right? So we got that. Now, for s, I have s to the negative 2 on the bottom. I want to make that exponent positive. So what do I do with this? Yeah, so I have s to the now positive 2. And then I initially have s on top. So I don't move that one because it has, think of it as positive 1 as its exponent. And now we move on to the next variable. Okay, so now move on to t. So t to the negative 4. Well, again, I want to make that one positive. How do I do that? And then what about t to the 2? Right, it remains on the bottom because it's already positive. And then we have 3, and then s to the 1 and s to the 2. What do I do with those? Yeah. So that will give me s to the third. And then what about the t's? Yeah. Uh-huh. Right. So that, and then s and t are different variables, different base, right? So we can't really combine them. So we conclude that's the answer. So the reason I'm able to move them is because of law number 7, right? So if you look at this law, it tells us if your exponent is negative on top, think of it as this is over 1. And in order to make it positive, you replace it on the bottom and it becomes positive. Or if you want to modify this, if I have 1 over a to the negative n, and if I want to make this exponent positive, I would have to switch its spot and put it on top. So that would be a to the positive n over 1. So if the t to the 2 was negative, then I will have move it on top. Yeah. So, no problem. So whichever exponent is negative, you're only moving that one. Okay. Go ahead if you have a question. So someone had their hands up. Uh-huh. Okay, great. So let's start. So tell us. Uh, mm-hmm. Absolutely. Any questions on this? Now, you could have done this question differently as well. So there's another approach to it. What would be another approach to the same problem? So remember law number 6. Uh-huh. Yeah, right? That would be another way. So you could do y to the negative 2 over 3 to the negative 2 and z to the negative 6. And now you have to swap them because they're all negative. So whichever is negative on top, you bring them on the bottom, and whichever is negative on the bottom, you bring them on top. So y to the negative 2 has to go on the bottom, and then it becomes positive 2. And 3 and z's, they're both going to move on top because they both have negative exponent. So that'll be 3 squared and z to the 6. And then the last thing is to evaluate what 3 squared is. That's 9 z to the 6 over y squared. So same answer. Ooh, big equal sign, right? So, make sense? All right, cool. Hopefully it makes sense. I have, here's another one. So let's try this one for next. We have a couple more minutes left. So I'll give you guys like a minute to finish this one. So let's call this example 6. All right, so let's go ahead and start. So again, there's two ways you can do this problem. So let's have someone tell us one way to do this problem. So let's do that. So we can go ahead and right away make it positive, the outside exponent, and we flip the fraction. So we have 5s to the negative 1 times t, s to the 2, t to the negative 4. So exactly in the same order, all we do is just swap them. That's it. What can we do now? Mm-hmm. Okay, so we made the s's positive. Now what about the t's? Mm-hmm. Good. So we're gonna move this one on top because it's negative, so we make it positive. And we don't have to move the other t because it's already positive. So we keep that t on top, and then we move this one on top. And everything is still raised to a positive 2. What can we do now? So we can do something more. Uh-huh. Raised. Absolutely. So now 5 gets a power of 2, which is 25. T to the 5th to the power of 2, that's t to the 10. And s to the 3rd to the power of 2, that's s to the 6. And that's it, right? T and s's are different variables, so we can't do anything. So that's one way to do it. There's another way to do the same problem. What would be another way to attack this problem? Uh-huh. Mm-hmm. Right, s to the 6. Yep, there you go. So again, you have two ways to do the same problem. So exponents are pretty cool, right? You have more than one way to do this problem. You just see which way it comes to you, right? It should be natural. If not, then you probably want to practice a lot of problem. And then when you see it on a test or a quiz, it should come to you naturally. Oh, I should do this first. I should do that first. Maybe I will do this way first. Maybe this way is easier. It should really kind of talk to you like talking math. Okay, so hopefully this makes sense. I do have a couple more, but I'll hold on to those until next class. Since it's already 11:15, I will stop the lecture here. So for the weekend, finish up P1 if you haven't yet, P2 if you haven't yet, and must complete P3. So those are due this weekend. So P1, P2, and P3, they're due September 6th. So make sure you finish those. And at this point, everyone should have access to WebAssign since our first quiz is going to take place today. All right, so I'll stop the lecture here for today and we'll resume again Tuesday.